Welcome everybody to this webinar about PRAESENSA networking with the topic RSTP and hop count. My name is Jan-Pieter Smolders. I'll be the host for this webinar. So Peter Ophey, the application engineer based in Eindhoven in the Netherlands, he will be the presenter for today, and I'm your host, Jan-Pieter Smolders, also based in Eindhoven. Okay, Peter, yeah, please start the webinar. The stage is yours.
Okay, thank you, Jan-Pieter, for the introduction. These are the topics for today: RSTP and hop count, and we will tell you something about RSTP, rapid spanning tree, and also about hop counts because they go very close together. I'll tell you something about history. It's not real history, but how it came to that we have RSTP, how it is used in PRAESENSA, and also how the hop count works in PRAESENSA. Okay, let's have a look at history. Well, actually, history, we are talking about loops in an Ethernet network. And the first question, of course, is why do we need a loop in a network, in an Ethernet network? And that's basically quite simple. You see here a very simple diagram of a network. Yeah, and there is no redundancy in this network. So if one of the cables breaks, so somebody cuts it or takes out a cable from a switch, immediately, yeah, you will lose that part of the network on the right side. There is no communication anymore between the two parts because there is just a cable missing there between the two parts. Yeah, so this could be, especially in industrial environments, could be very bad to have this happening, especially if you are controlling machines and so. Yeah, so it is measured in downtime, so cost per minute, and it is of course very important to fix this very quickly then. Yeah, and especially in industrial environments, a long recovery, a long repair for this problem will have a serious impact on the process in that factory, for instance. So what do? We create loops in an Ethernet network, but loops in an Ethernet network is quite bad. It's dangerous, yeah, because what will happen if a PC sends out a broadcast message, it will be repeated in every switch, and it will go to all the ports connected on that switch, and it will go to the next switch. Yeah, but those switches will do the same. Yeah, so the broadcast traffic is arriving at this switch. It will forward it to this host C. It will also forward it to the switch on the right, but it also already receives the same information. So that is also broadcasted, sent to the other switch. And you see what's happening. Yeah, all the switches will forward the broadcast traffic to the other ports, and you will see that you get a lot of traffic on this network. Yeah, and data package will go on the network very quickly and in this loop, and that's not what we want. Yeah, the packets multiply, and at a certain moment everything will go wrong, and it says a final resulting in a broadcast storm, resulting into an entire network breakdown. Well, that happens in a few milliseconds. That is so very fast. The moment you make this connection, the network will collapse immediately. Yeah, we've seen that already several times when we do a training for PRAESENSA, that if you make a wrong connection and there is no RSTP switched on, then the system is down in the moment you plug in the connector. So this is not what we want. Now, loops in this network, when there is no RSTP, that is not allowed. The network will collapse immediately. So what can we do to avoid loops? Well, there are a few solutions for that. And you see already, if you look at the dates for the different protocols, that this is not something new. Yeah, RSTP spanning tree protocol is already quite old, from the 90s. and then RSTP, the faster protocol, rapid spanning tree, is 2001. So this is not really a new development. It's quite old already. There were some combinations of the spanning tree and rapid spanning tree, and there is also a multicast spanning tree. We'll see that in a moment. Yeah, but what these protocols do is basically interrupt the loop. Yeah, and it's a blue cross. It's not a red cross where something is broken. It's a blue cross, and that means the connection is still there, the cable is still there. It is only that the broadcast traffic on the network is interrupted there. Yeah, so the connection is still there. It is just that the RSTP protocol will interrupt data on that cable. So then the loop is automatically interrupted. Yeah, quickly, what is the difference between STP and RSTP? The STP protocol is quite slow, yeah, 30 to 45 seconds, yeah, to restore. And if you look at RSTP, it is very fast, yeah, 100, 200 milliseconds. That is a normal switch over time. Yeah, and we see that also during the training and the test that we do here. You hear a small glitch on the audio, and that's all that you notice from when you disconnect the cable. Yeah, and then of course multiple spanning tree, something we are not using, not right yet now, but perhaps in the future we will also use that. But for now we are using RSTP, rapid spanning tree. Well, how does it work? We've seen that already. A connection is interrupted if you have a loop. Now in an RSTP network, yeah, there is always an RSTP root switch, and we call that the root bridge. Yeah, this root bridge is the center of the network. Yeah, so how you have to see that. Now the protocols are as follows. First of all, find out where the root bridge is. Yeah, you can force it to a certain device, but if you don't do that, you have to find it out yourself, and that's not so difficult. You see that. Yeah, and then if you know what a root bridge is, then the other devices will find the shortest way to that root bridge. Yeah, and in this case, it is the cable over there and this cable. And the other connection, that is this third connection, that is blocked. So you see the blue cross again. It is not disconnected. It's just that data is blocked on that connection. Yeah, so from the two switches, the best way to the root is via this connection and via this connection, and the connection in between is just interrupted. How is this in PRAESENSA? Yeah, well, I mentioned already, you can find out yourself who is the root bridge, and you can also force a unit to be the root bridge. Yeah, and what you, for those who have worked with PRAESENSA or have been in the training already with PRAESENSA, you know that each PRAESENSA device has a switch inside, a network switch. Yeah. Now, every switch in a network, whether it is a PRAESENSA switch or a third-party switch, it has a bridge priority value. Yeah, even the switch that, well, the switch I have here at home, it's a D-Link switch. It's about 45 euros, very cheap, but it is also, it has a bridge priority value. Yeah. Now, if you look at bridge priority values, it means that the lower the bridge priority value is, the higher the bridge priority. Bit confusing, yeah? But if you have a low bridge priority value, you will have the highest priority for the root bridge. And it works like this. You see here, we have a device and we have a root bridge priority, and you see PRAESENSA amplifiers, PRAESENSA call stations, they have a root bridge priority of 61,440. Yeah. If you go to the MPS, it has a lower bridge priority. Yeah. Then we go to the advantage switch. Even lower, even better. Yeah. And you see here the system controller 4960. This is for the PRAESENSA devices the lowest bridge priority value. So in a PRAESENSA system, this would mean that the system controller is always the root bridge. The root bridge for RSTP. Yeah. But if you now take a third-party switch, doesn't matter if it is a Cisco or a HP or a D-Link, a very simple one, it will always have a lower bridge priority. You see, 32,000. Yeah. So that means if you connect any switch to a PRAESENSA network, it will automatically assume the function of the root bridge for RSTP. And that can be quite dangerous because there's a big difference between a D-Link switch that I have here of 45 euros or the switch in a system controller. Yeah. So it is either the system controller is the root bridge and I don't connect any other switches, or what I also can do, if I have a managed switch, I can change the bridge priority. Yeah, and then I force it to be the root switch. Yeah, so this is a value that you can then select in the switch, in the configuration of that switch, and you have to make sure that it is lower than the system controller, but also lower than the third-party switch. Yeah. So you go to a value like this, 28,000 or so. Yeah, and then this switch will automatically be the root switch. Yeah, so that is how you determine which of the switches is your root bridge. Yeah, so default in a PRAESENSA system, it is the controller. But if you have a larger system, and we'll have examples of that later on here, it is sometimes better to have a third-party switch, and then we prefer, of course, the advantage switch, this PRAESENSA switch. We can change this priority to 28,000. And then that will be the root switch. Okay, so this is how we determine who is the root switch. Now, if you look at a computer network, what you will often see is that you have layers in this. You have the backbone switch, you have the distribution layer, and you have access switches. So the root bridge is on top, and then we have switches in below that. And you already see that for RSTP, a lot of the connections, which are cables, of course, Cat5 cables or glass fiber connections, they are dashed lines. So the actual connection is the black line, and all the other lines are backup connections. Yeah, if you translate this to PRAESENSA, yeah, you get the system controller on top, the advantage switches just below it, and then MPS, call stations, amplifiers below that again. And you see also the same layers. You have the backbone, the root switch, you have the distribution layer, and you have your access switches. Yeah, and you also see what happens here. The connection is the blue line here, and all the dotted lines, that are connections that are interrupted. The connections are there, but there is no data going over it. Only when one of the connections is disconnected, cable is cut, then the cable, the second cable will be active, and yeah, everything will work as before. Now, there is one important thing, and we'll come to that in the second part of this presentation, that the number of hops, and that means every time that you go from one unit to another, it is a hop, it does not exceed 22. We'll come to that later. Yeah. Now, if you have a small system and you have to make a small setup, you could end up like something like this. You have two controllers, an MPS for power, for the amplifier and the call stations, and you could connect it like that. Well, what you see here is that you have a lot of redundant connections. So this is a redundant connection. This is a redundant connection. So it looks very nice. But also keep in mind that the MPS here is a single point of failure. You can have all kind of nice redundant connections in your cabling, but if the MPS fails, all the connections are gone. So that is not so good. So you have to take care of this as well. And the simplest solution for that is just to go from this controller here, immediately to this third layer with the direct cable. And then you see already that if the MPS fails, the network part of that fails, you still have a secondary part over there. Yeah, so this is important when you design your network. So that was the part about RSTP. Now we go to hop count. Hop count. Hop count is about how many devices are connected, and then especially connected in a daisy chain, so a loop-through connection. Yeah, so we'll have a look at what a hop is, how to count, what are the limits, is very important, and how to calculate this. Yeah, and it's not that complicated. Yes, first of all, what is a hop? Yeah, if data passes through a switch, yeah, that is what we call a hop. So here we have a system controller. You probably have seen this symbol already before because it's the symbol that we use for Visio drawings. Yeah, you see the system controller, and the system controller has a switch inside, as any PRAESENSA device has. So every time that data goes from one connection to another connection over there, that is what we call a hop. Yeah. Now, here we have a small overview. We have the system controller here on top. We have an MPS call station connected. Via a glass fiber connection, we go to another MPS, and then we go to an amplifier. So here we have the route for RSTP, and here we have an endpoint. Yeah. So if you now look at the number of hops, this is the first hop, this is the second hop, and here we have the third hop. Yeah, so from the route via the MPS to the call station, that are 3 hops. If we go to another endpoint, and in this case that's the amplifier, then you see then we have 1 hop over there, 1 hop over there, 1 hop over there, and here we have 4 hops. 4 hops between the route, the controller in this case, and the amplifier. Now, why are these hops and the hop count so important? You see here a diagram. You see here the root switch, that's the controller, and this 1, 2, 3, 4 hops. But you can also count via the other way. 1, 2, 3, 4. And this is a loop, and you know that RSTP will interrupt the loop somewhere. Yeah. Now that somewhere is the farthest point away from the root switch as possible. Yeah, so the root switch is here. So which connection will be disconnected here or will be blocked? That is either this connection or this connection. Yeah, so you have 4 hops via this way, and then this one is disconnected, or you have 4 hops via this way, but then this cable is disconnected or blocked, the data is blocked. Why is hop count so important? Well, that's actually quite simple. You can have a maximum of 22 hops for RSTP. Yeah, so if you look at it like this, you can have a maximum of 22 hops to the endpoint. What happens when you go over those 22? Very simple. You lose everything after 22 hops. Yeah, you have the connection to those devices is lost. Yeah, this is a bit strange. You still can have 43 devices in a loop. and that will work. But the moment the loop is interconnected or there's a cable disconnected somewhere in the system, you will lose part of the system. Yeah, but always keep in mind what RSTP does. You have the root, you have, in this case, 2 ways to get to the endpoint, and one of them is blocked. It's either this one or this one, far away from the root switch. Now, we have here a diagram, and you see this is quite a large diagram with a lot of amplifiers. Yeah, these are again the Visio symbols. You see the switch, that is the root bridge, and you see 2 branches. So on one side, you see 22 hops, 22 amplifiers, and on the left side, you also see 22 amplifiers. Yeah, and what RSTP does is it will interrupt the connection far away from the root switch, and that is in this case this cable. This cable, the data is blocked. So you can have here this blue cross. Connection is still there, but there is no data there. So we have actually 2 branches now, and 22 hops is allowed. You know that. This side we have 22 hops. On the left side we have 22 hops, and this is working, no problem. The question now is what happens when somewhere a cable is interrupted, when somebody disconnects a cable. Yeah. So let's say this cable is disconnected. Yeah. Now RSTP, what RSTP will do, it will restore this connection. Yeah. So this blockage of data will be taken out. And you see what happens now. We have 22 hops here, and then this is 23, 24, and so on. It's 2 times 22, I see now. Okay, but what you see here is more than 22 hops. And that means those devices will be lost. Yeah, the system will work because these amplifiers on the left side we have no problem, and on the right side we will have only the amplifiers up to hop number 22. Yeah, so that is why we say no more than 22 hops in a loop. Yeah, because if then something happens in that loop, you will all the 22 hops will still work. And if you have more, yeah, you see what happens here. The moment you have more than 22 hops, you lose part of the system. So how can you, well, calculate is of course a large word for that. How can you imagine that? Well, here we have a small diagram, and here you have layers for the hops. Yeah, and we have the root switch on top, that is hop number 1. And then we have the branches on the right and on the left, MPS call station or amplifier, amplifier, amplifier. You see, this is 1 hop, this is 2 hops, 3 hops, 4 hops. Yeah. Yeah, what you can do, look at it as a chain, yeah, a necklace. Hold the root in your hands, and then you can lift it, and you see this is level 2. These are the 2 hop number 2, hop number 3, hop number 4. Yeah. And you know that we can have a maximum of 22 devices, but in this case, there is no problem at all. We have 4 hops and that's it. Yeah. Okay, what happens when this cable is disconnected? Well, you get more hops, because what will happen is this. The chain will fall down, and we go all the way to 6 hops now, because there is no return path. This is no problem. The system will work. Yeah, and you will get a message that the ring is interrupted. A more complicated design. We have 2 systems, perhaps a bit difficult to see, but we have 2 systems here, one on top, where we have, just for this example, a controller and 2 MPSs, and then you see the red lines, glass fiber connection to another location. Yeah, so this part on the left is a remote location for a system. Yeah, or part of that system. Yeah, what you also see here, it is a loop. If you look at this line here, but you also have a loop like this. And back to the controller, you even have a loop here. And that is for RSTP, no problem. You can do that. Yeah, RSTP will take care of that. Yeah. And again, we can take this, the root switch here, the controller, and you see what happens if you look at the chains. Yeah, we have 6 hops here. Yeah. But now, if a cable is cut, what will happen then? Yeah, let's say this cable cuts. If this cable is cut, and then you know the chain will fall down. Yeah, and it will fall down to this. Yeah, so this connection is lost here to the MPS, and so it falls down. You see 1, 2, 3, 4, and you go down here, and now we have a maximum of 7 hops. Still, this is no problem. The system will work. Yeah, but if we now also take out this cable, yeah, and now what you see here now is we are taking worst case scenarios, but that's what you have to do. Yeah, and that you have 2 faults at the same time. Yeah, but what happens when you do that is then again the chain falls down, but still we have only 10 hops and we can go to 22. So this is still working. Yeah, it is just that you have more hops in your network. Yeah, still there is no problem here. Another example number 3. And what you see here is that we have a system at 4 different locations. So we have the system controller in one location. We go with glass fiber to a second location where we have devices. Then we have a glass fiber connection to a third location, and again glass fiber to a fourth location. And then to close the loop, we go back to the first system. So this is quite a large system. Yeah, it looks a bit like a heart. Yeah, but it's not so important. Yeah, but at this moment we have a hop count of 14. Yeah, you see that the different levels here, and in the end we have 14. And most likely the RSTP will disconnect the connection far away from the root, and that is this connection over there. Yeah, so that is the redundant connection that is blocked for data. What will happen if we now disconnect the cable, that cable? Yeah, you have to consider worst case scenarios when you do this. And you can also already predict what will happen. The chain will fall down. It will fall down a lot. Yeah. And now you see that we run into 22 hops, and then we lose certain devices. So if this cable, this fiber is interrupted, you see that we will lose at least an MPS and 3 amplifiers there. And that is why hop count is so very important when you're using RSTP. RSTP is default switched on in PRAESENSA. Yeah. If you go over 22, you will lose those last devices, and that's something you don't want, or you have to prevent that. Yeah. So the number of hops goes over 22, and after 22 hops, everything will be lost. So this design is not a good design. I have here another example, and then this is a already a more realistic diagram here, if you may say it like that. I think we made this for a system integrator some time ago. Yeah, where they needed a lot of amplifiers and then also the MPS and a few call stations. Yeah, but what you see already here is that we make different loops. I mentioned you can have loops, you can have multiple loops, you can even have a loop in a loop. That is no problem, and you see that here. Yeah, you see here a call station that is connected to 2 MPSs. At the same time, you see a wire over there on the other side. So you have a loop here. That is no problem. RSTP will disconnect or will block one of the cables. Yeah. Now, if you look at the loops in this diagram, and we have multiple loops here in this diagram, this is the first one. Yeah. You can always follow it later because the presentations will also be available later. Yeah, it goes from here via the MPS. Then we have 12 amplifiers. We go via this connect cable here to this MPS and we go back to the switch. Yeah, this is one loop. Another loop is this one. We have now the switch. Then we go via all the MPS here. And now we have 9 hops in this loop. Another loop is this one. From the controller, the root switch, to the MPS, via a cable to the amplifiers, amplifiers over there, MPS over there, and back to the root switch. This loop has 17 hops, yeah, if you count it. But there is another loop here, and that is this system, this remote system, that is connected via 2 glass fibers. Yeah, and you see this loop has only 10 hops. Yeah, via the amplifiers. And of course, the shorter route in this system is via this cable. Yeah, but you have to count worst case. So you have to count if this cable is cut and this cable is cut, and then data will go like this. Yeah, so you have to consider worst case scenarios. Yeah, and here we have 10 hops. That was everything I wanted to tell about RSTP and hop count. Those two things always go together. When you have switched on RSTP, and that's default in a PRAESENSA system, you always have to do your hop count. Don't forget. One thing that's important, if you have to do a design like this or even a bigger design, you're not sure, send it to us. We can check it for you. For us, it's also a learning thing. Yeah, we also have to know how customers use PRAESENSA. Thank you for attending this webinar and hope to see you soon in the next one.